In this video, we're going to cover the Leibniz rule, which is a generalization of the product rule to taking repeated derivatives of a product of two functions. First, think about how we would find the nth derivative of the product f of x g of x. We'll end up having to apply the product rule many times. Here are the first few derivatives of this product. Do you see a pattern? The pattern is that the nth derivative of the product f of x g of x is this sum involving binomial coefficients. This observation, which ends up being true, is known as the Leibniz rule. The Leibniz rule can be proved by induction, but in this video, let's just take a look at the intuition behind the rule. Before you combine like terms, the terms of an nth derivative of a product correspond to the set of binary vectors of length n. Another way to think about it is that any given term in the nth derivative of product was derived at by making n binary decisions, where the decision 1 corresponds to differentiating the f function, and the decision 0 corresponds to differentiating the g function under the product rule. When we do combine like terms, all that matters is the number of 1s and 0s in our decision vectors. The number of 1s will be the order of the derivative of f, and the number of 0s will be the order of the derivative of g. Finding the coefficient on a given term after combining like terms is therefore done by counting the number of binary vectors of length n with a given number k of 1s, which is nothing more than n choose k. Let's do an example now. Let's find the third derivative of the product of functions shown here. To use the Leibniz rule, you can set up a table to hold the derivatives of f and g. We're going to be taking the 0th through 3rd derivatives of f and g, where by 0th derivative we mean don't take any derivative. Once we have those derivatives, we'll compute the sum that appears in the Leibniz rule. Feel free to pause the video and compute these derivatives yourself. The summand corresponding to k equals 0 will be this. And here is the summand corresponding to k equals 1 in blue. And in green is shown the summand corresponding to k equals 2. And finally in red is shown the summand corresponding to k equals 3. Adding up all of these summands, we get the following result for the third derivative of our product of functions. The Leibniz rule is also useful theoretically in deriving explicit formulas for nth derivatives. For example, the rule is useful if you want to find the nth derivative of some product of functions f of x g of x, where you can easily find, or you already know, an explicit expression for the iterated derivatives of f and g separately. That's all for this video. Thanks for watching.